So good morning, everyone, and hope all of you are doing well. And I am Debpriya Sarkar, and as Aishwarya mentioned, I have my friend and colleague Amod Ankulkar with me, and we both work at SAS R&D Center in Pune. And today we're going to talk about some of the environmental related challenges and how we can make use of analytics in order to address and solve some of those challenges. Specifically, we will discuss about the challenges related to rainforest. Rainforest is a word that you will hear a lot throughout this presentation. So I think many of you may already be aware about what a rainforest is. However, just to give you a very quick background about rainforest, so it is a area of tall, mostly evergreen trees and a high amount of rainfall. So such an area is typically called a rainforest. Rainforests are Earth's oldest living ecosystems, and there are still some surviving rainforests which have been for millions of years. They are incredibly diverse, complex, and rich with flora and fauna. Rainforests tend to thrive on almost every continent, except I think Antarctica. So then why are even rainforests important? Why are we even talking about rainforests today? So rainforests typically have a very rich diversity and is incredibly important to both human as well as ecological well-being. Rainforests also help to regulate our climate and provide us with everyday products. And they also play a very, very crucial role in producing a large percentage of our global oxygen supply. Having said all of that, let's talk about some of the key challenges or threats faced by rainforests. Now, sadly, some prominent rainforests today are being ravaged by rampant degradation, and hence the degradation is putting the rainforest at the risks of turning them into dry grassland. And of course, there's also man-made forest fires, which have a significant impact on the environment and ecosystems. The fires are mostly lit by humans to clear the land for activities such as ranching and farming. Expansion of ranching and unsustainable farming also comes across another challenge or threat to the rainforest. Also, there are different land uses in deforest regions that can have very, very different impacts on the climate and environment. Land use changes expose the rainforest to environmental threats. And some questions become very important to consider. So what are those questions? Is it possible to reduce the environmental impact due to suboptimal use of land? Which type of land use contribute most to the biodiversity? Or what are the different types of land use that show the most potential to absorb carbon? How do we plan to promote sustainable agricultural practices? Which type of farming should be considered to conserve biodiversity? So these are some questions that become extremely important. Also, there is a significant consequence of forest fires, for example, are carbon emissions. And they can go to levels where the rainforest may actually emit more carbon dioxide than it absorbs, which is again a significant concern, which jeopardizes the environment. Apart from all of this, there are also illegal mining activities that causes significant ecological impacts. These activities, they lead to loss of biodiversity for a rainforest. Now let's consider Amazonia for today as our case study. And I'm sure many of you may already have heard about Amazonia. It is the world's largest tropical rainforest, which spans across the South American continent. The Amazon rainforest actually covers about 40% of the South American continent, which spans more than, I think, 1,600 million acres. And they span across 9 different countries, out of which Brazil, Bolivia, and Peru are the prominent ones. These 3 countries, cumulatively, they contain about 80% of the Amazon rainforest. Despite its acknowledged importance, unchecked deforestation is taking Amazon closer to its tipping point. What do I mean by tipping point? It is taking the rainforest to a point where it might no longer be able to generate its own rainfall and support its own ecosystems. Based on estimates, the current deforestation level of Amazon is at about 17%, and its tipping point is at about 20 to 25%. Now, if the tipping point is surpassed, the largest rainforest on Earth could become a grassland. Deforestation of Amazon not only has, I think, economic implications, but also have a major impact on agriculture, crop production, ecosystem, and of course on the local community as well. So conserving the Amazon rainforest is essential to ensure a healthy future. So then, circling back to the challenges that we discussed previously, we are going to mostly focus on a couple of challenges. Number one, how do we actually try to reduce the impact of forest fires? And number 2 is how do we make proper use of land? And we'll try to discuss some possible ways on how we can leverage analytics to deal with these specific challenges. Now, how did we start off our journey? So our journey started with one major question, which is how can analytics help sustain the Amazon rainforest? So we started off by asking what data is available to us. So once we did get hold of some data sets, we explored them and assessed them based on quality, usability, and relevance. And the next step in the whole process was to pre-process and restructure the data sets so that it becomes useful to the subsequent analysis. And then the processed data was then analyzed using statistical techniques and machine learning algorithms to yield insights and to understand what is possible in terms of action items. So first off, let's start to talk about the Amazon rainforest. And I have a very quick infographic for you. Now, as we already mentioned, fire is one of the drivers of deforestation in the Amazon basin. And just in about 2019, about 20 million acres of Amazon were devastated by fires. Now, once we got hold of the data sets related to fire, I think we tried to look at the numbers for specifically Bolivia. And these are some of the findings when we started to explore the data. So if you look at the charts here, you can easily guess that there is an increasing trend of fires in Bolivia from 2018 to 2020. Now, if we compare the number of fires across the months of a year, it shows an increasing trend from July to November, maybe peaking around September, October. And this is an indicative of fire season. So July to November is typically uh, the fire season in the Amazon rainforest. And these were some of the findings we had when we started to explore the data. And this analysis helps us to understand also the scale and the pattern of forest fires. And the further analysis based on this data was performed for the months from July to November, because that's the fire season that we just talked about. So then how do we find a possible way to reduce the impact of fires? So this was our problem statement. And as part of a possible solution, we asked whether it was possible to identify the areas where fires are more vulnerable, and is it possible to determine optimal geolocations where we can establish firefighting base stations. So given the data sets, we process them for further analysis. And the two data sets that we looked at were the fire data set from NASA, and the other one was the aerosol data set, which we got from Sentinel-5P, which is basically a satellite commissioned by the European Space Agency. In order to make the analysis more manageable, we focused on the data only for Bolivian region. And this was based on the recommendations we received by the experts at the Amazon Conservation Association, which is a non-profit organization working to conserve the Amazon basin. Now, it's an obvious exercise to look at the fire data set, but one may ask, why are we even considering the aerosol data? So what happens when fires burn? They actually emit aerosols that are minute particles suspended in the atmosphere. A large fraction of human-made aerosols come in the form of smoke from burning tropical forests. So discussions based on the experts led us to review the aerosol data, and we believe that aerosol levels could be an important factor towards detecting fire. So let's discuss a little bit more about how we conducted the analysis. So we did a couple of analyses. One was with the aerosol data, and the other one was with the fire data. So let's talk about the analysis related to aerosol data. So as discussed, this data came to us from the satellite Sentinel-5P. Now this satellite are armed with sensors that can measure the aerosol levels globally. Processing the aerosol data that we got from Sentinel-5P was a really challenging step, where we had to process multiple raw spatial data files. Just to give you an example, just for the year 2021, I think there were around about 625 different raw files just for the months of from July to December. So that's the volume of the data that we have. And for each month, there were about 1 million rows in the data files. So it was really challenging to process all of that data. But we tried to do that, and we consolidated the data for across the months. And to improve the quality of the data, we tried to clean it, filter it, and we also removed unnecessary variables so that we could reduce the redundancy in the data. From there on, the data was aggregated based on the different regions for Bolivia. And once the data was processed, the next step was to perform geostatistical smoothing. And why do we do that? Because we wanted to reduce the noise in the data. And this is an excellent model or a technique to reduce the data, reduce the noise in the data, and to interpolate the aerosol values. Now, this is basically a regression technique which interpolates and smooths the data. It differs from the regular regression technique in a sense that it uses spatial correlations between sampled points to interpolate the values in the spatial field. And the interpolation is based on the spatial arrangement of the empirical observations we have in the data. So in a general sense, the kriging weights are calculated such that the points nearby to the location of interest are given more weight than those that are farther away. And in order to compute a suitable spatial covariance structure is required before we compute the weights. So that's where we find the spatial covariance structure first. And once we get that, we just input that into the kriging model. And the model then smooths the data and generates the predicted values for aerosols. And this might be useful for us to get some insights about the data. And we are going to see a visual next where it might make more sense. So we try to visualize the aerosol data that we got from the model onto a map of Bolivia. So this is the report or the graphic that we did once we completed the modeling step. And the results are reported here in the form of a visual. So in this graphic, we focus on the Bolivian region. And we've done a side-by-side comparison of the fire spots, which are on the left, and the estimated aerosol levels are on the right part of the visual. Now, these estimated aerosol levels are generated by the geostatistical kriging model that we just discussed earlier. Now, typically, higher levels of aerosol are indicative of fires. The aerosol levels here are estimated for the entire fire season, and they do tend to display an increasing trend from July to November, and it peaks around September. Now, this is obviously a static visual, but this report can also be made interactive, where all of these estimated aerosol levels can be toggled across multiple months of the fire seasons. And users can get insights about the aerosol levels across Bolivia. And this can be extremely useful to users in order to determine the geolocations of fires in Bolivia during the season. For example, here we are seeing a region which has a higher level of aerosol value. So this could be a vulnerable area in terms of fire and could be a possible candidate to establish a fire station. So with that, we will move on to the second analysis here. Now, this part of the analysis, we considered the fire data, which we got from NASA. Just like the European Space Agency, NASA also has several satellites in the space, and they tend to capture a lot of data related to fire. There are special sensors in the satellite which capture active fire spots. And all these data are made available by NASA. So in this analysis, we've made use of that data. So here the idea is to again identify geolocations for vulnerable areas where there could be possible base stations. But we've taken a slightly different approach here. Here we are trying to do clustering on the fire data and to come up with the geolocations. So just like in the previous analysis, first when we got the data, we had to clean it up. We had to pre-process the data, and so that we could uh, uh, tailor it or customize it based on the needs of the analysis. So again, this was the data was acquired for Bolivia across the fire season, and we took about 6 years of data from 2015 to 2021. And there were, I think, more than million data points across all the 6 years of data. So once we processed the data, next step was we did the k-means clustering, which was done based on locations. And k-means clustering is a very popular machine learning algorithm, which can create partitions in your data based on the patterns. So that's what we used. And once we clustered the data, we found the centroids for each of the clusters, which is essentially like a midpoint of each of the clusters, which can actually help us to determine the locations for the base stations. So again, once we did the analysis, we used a graphic to report the results. And this is the visual that actually represents the various stages during the analysis. So here in the first visual that you see, so these are the fire spots data for Bolivia across from July to November. And there were about 905,000 data points here. So we ran the cluster analysis in 2 steps here. So the first step was to use the clustering based on all of the 6 years of data. And then we reduced that to around 2,200 clusters, so which you're going to see here. So we basically did the first step of clustering here. And then we did a second step of clustering, and we also factored in the intensity of fire in this case. And then we ultimately had 14 clusters. And then we found out the centroids for each of the 14 clusters, which gives us sort of optimal locations for the fire stations again. So we started off with a lot of data, and using clustering, we reduced the data to just 14 centroids or 14 locations. So that's what we did in this particular analysis. And I'd like to mention that the number of clusters here are not fixed. They are flexible and they can be changed based on the feasibility and location of the fire station. So this was all about the discussion on the challenge of rainforest fires. So using analytics, we can devise multiple data-driven approaches that may actually help in coping with the challenge of reducing the impact of rainforest fires. The ideas discussed in the analysis can help us to find optimal locations for firefighting stations. And armed with all of these insights, perhaps the local authorities and administration can plan ahead and prepare for the fire season to combat and limit the damage and impact of the fires. Next up, I think I'm going to give it to Amod, who will talk about dealing with the other challenge. Over to you, Amod.
Thanks a lot, Dave. So Dave has worked on addressing the problem of forest fires And our team has worked on addressing the challenge of suboptimal use of forest land. So what is meant by suboptimal use of forest land is basically there are different types of lands like forest land, arable land, where you can actually grow the crops. Then there is meadows, and one is used for pasture, that's for cattle grazing. So there are different kinds of use, and in that particular use also, let's say if we take arable land, what crop should we grow there? Now, there are various kinds of crops that we can grow, and each crop has got its own benefit as well as uh, it has got impact on the environment also. So we have to see, we have to strike a balance. We don't have to lose our revenue. At the same time, we have to minimize the impact on the environment. So there are various measures to measure the impact on the environment. The first measure, of course, is the degradation, percent of degradation. So this is something that is available from uh, the data that we are going to look in the next slide. So our problem statement clearly was to minimize environmental impact caused by the suboptimal use of forest land in Brazil. So as Dev's problem, he addressed the problem specific to the Bolivia. And in our case, we were addressing the problems which was specific to the Brazil, because Brazil occupies almost 65% of the land, and then policies that the Brazil adopts while selecting how to choose the land dramatically impacts the global economy also. So in that way, Brazil was very important case for us. And then what we tried to do as a solution is to propose a crop mix. You can think of it as a mix optimization problem, where you can actually select this percentage of land I'm going to use for, let's say, rainforest harvesting. This percent of land I'm going to use for growing the crops, particularly the soybean or Brazil nuts specifically. And then you can the variables to optimize are first the environment, because we are very much concerned about the environment here. And then at the same time, you also have to take the revenue as another variable, because we just can't think of, because even if we are able to convince any country that you have to minimize the impact on the environment, but at the cost of revenue, so nobody will listen. So obviously, we have had to take the impact on the revenue. So we tried both variables and we tried to optimize them. And for that, we used two data sets, which are publicly available. We don't have to ask for them. So the first is FAO Stat, Food and Agricultural Organization. Statistical Department maintains this data set. It's a US Statistical Department. And it has got the data for almost 245 countries. And the data has been maintained from 1961. So almost since 60, 70 years. For 60 years, the data is being maintained. And there are a lot of other sources from which the data is gathered. For example, with some research institutes, they give the data to FAO Stat. Some international organizations, they also do some study and give the data, share the data with the FAO Stat. And the governments also share the data with the FAO Stat. So FAO Stat has got a variety of sources from which it collects the data and maintains data regularly. And it contains the data about food production, food consumption, how much food has been produced, how much has been consumed, what is the quality of the soil every month in every region, almost for 245 countries, what kind of land use is characteristics each country has, and what kind of soil quality, what is the water availability to grow the crops and all other things. What is the nutrition value of the crops that are produced by those particular countries. And this helps us to actually understand the food security problems, food insecurity problems, I should say, because some of the countries are not able to produce enough food which is required by their population. So In that case, some organization intervene there and then they do some policy changes or they do some kind of a trade. So this is the data set which is used uh, by us for analyzing the land use. And there is one more data set which is a common trade, and is maintained by the United Nations, and it is all about the commodity trades. So there are a lot of commodities uh, and crops also become a part of that. And what all transactions have been done, that is exports, imports, what is the volume of the export and import, and what is the value of that export and import, and how that is overall impacting your own economy, that is whether you are gaining or losing. Uh, so all that sort of analysis can be done using the concrete data. So so we also use the concrete data, and these are the two sources from which we gathered the data. Now, let us come to the visualization here. So we have just concentrated on the specific window, that is 2000 to 2019. So the 20 years, over the period of 20 years, we have collected the data for 3 countries, not just Brazil. Just we wanted to make the comparison fair, and we wanted to analyze what is it that is causing Peru to have the minimum degradation of the land, whereas the Brazil continues to degrade very drastically. If you see in just the percentage numbers, you can see that the Brazil's land has been degraded for more than 10% over the period of 20 years. Bolivia also the same case. But interestingly, if you look at the Peru, so the degradation of land is just 3%. So Peru becomes our interesting case because there must be something that Peru is doing in order to address the problem of this forest degradation. So let's go to the next slide. And so, okay. So here what we have done essentially is we have used our forecasting technique just to see 5 years down the line, that is till 2025, how much degradation would happen. So if you see from the percent land, it's almost 58 to 60 percentage to 58%. So almost we are going to lose 1% of the forest land. 1% of forest land is a huge amount of loss. So it's just applicable for Brazil, but we have also analyzed this for Bolivia and Peru. So going to the next slide. So what should be our approach? So our approach was very logical in a sense. First, review of the business objectives. So we want to be more eco-friendly. Eco-friendly, eco means economy also, and eco means ecology also. So there are dual objectives kind of thing. So we have obviously our first and primary objective was ecology. So we have to be ecology friendly, and then we have to analyze the yield patterns of the land when we grow our soybean, when we grow it for pasture, for cattle. So cattle grazing is also one of the main use of land. And then if we grow some of the renewable crops like Brazil nuts or cocoa, then what is the yield pattern of that particular crop over the period of time? So we have studied that. Then of course it comes to the export. So how much are we able to export? Because if we export, then we are going to generate revenues of out of it, and that's why the export analysis also becomes very important. And we studied that for all the crops or all the patterns that were there in that data. And after studying the exports, then we try to build the model. So in order to build a model, we have to think of many ways. It's just not that the one model we try to fit, but we have to first find out all the underlying factors that were supposed to influence our target variable. Now, what is our target variable? Obviously, the target variable was degradation of land. This is the target variable. Also, the target variable could be the revenue, or the number of the amount of money that we have generated. So for this modeling approach, we have restricted to the degradation of land. And then when we have identified all other time series which are influencing this target variable, then we try to build a Remax model on that in order to project that how much, do some forecasting and see how much would we be benefiting from in terms of revenue, as well as how much would we be saving in terms of degradation. So this model, once we built, we also built further the mix optimization model, that is what if analysis. So what if I use X% of land for soybean, Y% of land for Brazil nuts, Z% of land for cocoa, and how much would I be benefiting in terms of degradation, and how much would I be benefiting in terms of revenue. So this is a logical flow that we have adopted throughout in addressing this problem. So going to the next slide, just this was the exploration. We got the data and we tried to just create some graph and see what is the pattern over the period of 20 years. I mean, we have restricted this to from 2000 to 2019. And this is the analysis of production of Brazil. Now on the left side, what you see is the renewable food resources like Brazil nuts. And on the right side, there are the land uses like growing soybean and using it for cattle grazing or meat. So it is clear from the graph that over a period of 20 years, Brazil has managed to increase the renewable food production by 20%, more than 20%. And cocoa, if you see, it's just a flat. And if you see on the right side, the soybean, the growth is more than 300%, which is very striking. And on the other side, the growth of the cattle is also more than 200%. So clearly, Brazil has got some policies that are, I mean, because of which it is stressing more on growing the soybean and cattle, and not stressing that much on the Brazil nuts and cocoa. So let's go to another slide and have a look at the Peru. Now, why we have taken Peru is, as we have just seen in the previous slide, that Peru was managed to contain the forest degradation a lot. And the graph is more evident. I don't have to explain, but let's just see quickly. On the left-hand side is the renewable food resources, the Brazil nut and cocoa. And if you see the growth, it has grown more than 150%, and the cocoa is grown more than 200%. And if you just see on the right hand side, let's say the production of soybeans. So in fact, the production of soybean has been declined over a period of 20 years. It is declined by more than 50%. And production of meat has grown from to 50%, more than 50%. But clearly there is a lesson to be learned here, that if we manage to grow more renewable crops like Brazil nuts and cocoa, we can still produce more, and we can also earn the good revenue numbers. And at the same time, we contribute more in terms of environmental protection. So Peru clearly has got a very less footprint when it comes to carbon, whereas Brazil has got a highest footprint. So that really drove us to analyzing the use of Brazil nuts and cocoa when we compare it against the soybean and meat. So again, you would ask why we are comparing soybean, cattle, and Brazil nuts. So just to give you a brief background, so Brazil nuts are very native to Amazonia. We don't have to cut the forest. We don't have to do the deforestation to grow the Brazil nuts. And the Brazil nuts trees, if you see, those are really 100 feet long, 100 feet tall, and they really allow other habitat to grow inside. I mean, many animals and many birds, they come and they live there. So it is a very natural habitat for a lot of species. So in a way, it helps us in increasing the biodiversity also. At the same time, we don't have to deforest the land, and that's how we we don't have to produce the greenhouse gases because of the deforestation. There is a loss, and also it prevents the soil erosion, because when we uh, grow other crop, let's say soybean, and so if you look at the soybean is primarily grown as a monoculture. So what we mean by monoculture is we have to just get rid of all the plants and deforest the land completely, then grow it and continue to grow soybean again and again. And what does that do is it affects the soil quality and it erodes the soil a lot, so that the land doesn't becomes infertile in a sense. So we are damaging the environment just by focusing on one crop. So that is the disadvantage of soybean. And also, when we grow the soybean, it attracts pests. So we have to again do the pest control. So even if we grow the soybean is under the threat also. And it is obviously not habitat friendly. Nobody can, I mean, for other species that live in, that are native to the Amazonia, it is not beneficial to grow soybean there. So that is why it drove us to compare the land use for soybean and the Brazil nuts. And if we are also see the land use for meat, so what does the again the cattle grazing do? Is when cattle graze, they compact the land, compact the sand on which they actually run or walk. And if the sand is compacted, again it becomes eroded and becomes infertile for the for growing crops. So, and also if we consider about the methane, so if we just look at the methane, a third of the human caused methane emissions are from the livestock. It's very alarming figure. And also if we say the livestock sector that contributes to almost 15% of the greenhouse gas emissions. It's a very significant contribution of the livestock. And also if we look at the use of fresh water, so we need fresh water for the livestock also, and for their land, for maintaining the pasture and all that. So 18% of fresh water is consumed by this livestock. So clearly, livestock contributes a lot in terms of soil erosion, in terms of fresh water, that is water scarcity, and also in terms of, and I'm not here the animal welfareists in this, because they will just say that just the sheer amount of pain that you inflict on the animals, and they will promote the vegan diet and all that things. But we are not discussing that here. We are just considering that is a valid use of land. But in spite of not even considering all that, we see that it is dangerous to the environment. And just imagine if we consider all these factors, which are again promoted by the animal welfare, this clearly doesn't suit well for any country to use the land for the cattle. Let's go to the next. So now we come to the analysis of exports, and the story remains more or less the same here. So if you just see Brazil nuts and cocoa, and on the other side, right hand side, you see the soybean and wheat. So one figure is in terms of millions and other is in terms of the billions. So obviously it is Brazil, and you can clearly see the increasing trend when you see the right hand side, and you can see the declining trend when you see the left hand side. Again, this data is for the 20 years window. So now let's go to the next. We compare this analysis of exports to Peru. Now, just because of the size of the Peru, the numbers, the overall numbers are also very less, but we can look at them relatively and percentage wise. So on the left hand side, we can clearly see the increasing trend. And the revenue they managed to generate was in millions, whereas if you see the soybean and wheat, it is declining, and the figure is also in thousands. So clearly, having more focus on Brazil nuts and cocoa, we can actually increase the revenue figures also, and we can contribute more to the environment also. So this is a dual objective that is served by Peru by its choice, just the choice of the land. And so moving forward, So now coming to the modeling. So this is the most important step here because that will tell us something more about the simple analysis of exploration that we have just gone through. Now we have to validate that analysis, and for that there are certain steps that we have performed. The first and foremost and the most crucial step, which took us almost 70% of the time, because is the data cleansing. So if you just see the data size, so it's a very huge data, and we had two data sets, one FAO-stat and ComTrade. So we have to again do some aggregation, do some joining, concatenating, in some cases imputing, because the grain or the time is for some crops or for some commodities it is month, and for some commodities it is year, and for some commodities it is day also. So this is the variability of the data, and we had to somehow bring them into a common bucket, and then after joining, aggregating, imputing, we then made the data ready for analysis. So this is really very crucial step and took most of the time, and oftentimes this is the most neglected step in the analysis. But for us or for any analysis, data cleansing is the most crucial step. Okay, so now we got the data, we joined the data, we aggregated, and we did everything. So now what to do? So we found that there were 14,000 time series variables, and really, if we try to analyze each and every time series variable, it is not feasible also. So what we had to do, we had to naturally cluster the time series, and for clustering, we had to use the similarity analysis. Now we clustered the time series and we clustered them into 8 clusters. Now each cluster has got many time series inside it, but those in those were sharing a similar pattern, and that's why they came in the same cluster. So after clustering the time series, obviously our variables got reduced, and now all we have to take is one representative from each cluster and then build some Remax model and see what causes the forest land to behave in that way. In other words, what are the underlying factors that are influencing my target time series? Now here my target time series is land use, as we have previously seen. And we also have to see what underlying factors are contributing positively, negatively, or how much extent they are contributing. So for this we use Remax model, and then after using this, we use the optimizing the mix. So I will just map it to the marketing mix optimization, which you might be familiar with more, because we have to choose the media and the right media that will generate the more revenue. So if you put 100%, 10% money in print, 10% in social media, 10% in television ads. So this is the mix of my advertising budget and how much revenue ultimately I will be generating. That will measure the success of my marketing campaign. So it is same thing, that is, but only in case of media, choosing the media, we are choosing the land. And let's say if we grow 10% soybean, 15% cattle, 20% Brazil nuts, and something like that. And this is my mix now of the land, entire land that is available to me. How much land use, I mean, how much forest percentage of forest land will I be able to preserve? And at the same time, how much revenue I would be able to generate? So both these are equally important. So this is a kind of optimizing the mix problem that we built on top of the Remax model. So going to the next slide is yeah. So interestingly, what happened is these are the variables, which are the target variables for land usage. This is arable land, agricultural land, forest land, pasture, permanent crop land, and so all those target variables, and it is quite obvious that those are related to each other, and those came under the same cluster. And for all other seven clusters that were there, we took some representatives there, like subsidies, stock variations, unemployment, and we found that these were dramatically influencing the target outcome. So whenever you have some subsidies on this particular, let's say soybean, then farmers will be more inclined to grow soybean. So subsidies really influence the optimum land or the choice of the land use. And same is the stock variation. That is the that is our commodities stock and the pricing variation. So if let's say for this year there is more price to soybean, let's grow soybean. So these decisions are driven by the stock variations also. There are a lot of there is unemployment factor also that we found to be influencing the outcome, because again coming back to soybean, soybean is very less labor intensive job, and therefore you can clearly grow soybean without employing much labor. So again, this unemployment was driving the decisions of the farmers or the governments, to be very honest. And there are others also, but we won't go into that because we just want to stick to these main important underlying factors. And of course, further interpretation is required because this is not the final interpretation. We can also experiment more and more. We can choose to do entirely different approach also, and we can handle and whatever the data or the figures that we manage to gather, that requires the interpretation from the domain experts also. Let's move to the other slide. Next slide. Yeah. So in the whole analysis, these are the crucial points that we need to take into account. The first and foremost is getting accurate data. Now, FAO stat and Comtrade being very accurately, very frequently managed, they still had inaccuracies because some research organization or the different sources that we have just talked about, international organizations, some research institutes, so they may give some inaccurate data to FAO stat. FAO stat verifies that data, but it has no foolproof verification methods to verify the data. So there are some innate inaccuracies in the data that we have to live with, because otherwise our analysis will be affected drastically. The second point is choosing the right mix. So when I say choosing the right mix, now here our mix problem was only limited to cattle, soybean, and Brazil nuts or cocoa. So we have chosen these four for our for us suggesting the right mix. But we can choose different combination of crops, different combination of land uses to have a mix. We can have 10 or maybe 20 also, depending upon the soil quality, depending upon our geographical advantages that every country has. It can choose to grow different crop. So this choosing of the right mix is also one of the things that we should be cautious about before following the approach that we have just seen. The other thing is use of advanced techniques in machine learning. So we here used Arimax model. Anyone can use a different model also in order to forecast, like neural networks. There are very sophisticated techniques that are being continuously evolved. So we can use those algorithms also, but we have to just keep in mind that choice of algorithm affects the accuracy and analysis of your analysis. And after our analysis is done, it's not that we have just fit the model and now everything is done. It's not like that. We have to continuously assess it. Periodical assessment has to be done whether our mix is producing the desired effects or not. And if it is not producing, then we have to again build the model, retrain the model, and see what kind of problems and investigate what kind of problems did we have previously that compelled us to correct our model. So this kind of periodic assessment is also required, and timely course correction is also required, because if, let's say, if our model is not giving us the optimum results, then if we change the model and model asks to do us something different, then we should be able to do them timely course correction in terms of your stock pricing, your subsidies and all that. So we have to do that also. So these all things affect the model accuracy. These all things, and if you just look at this, it requires a lot of commitment, because it's just not for the sake of doing. We are doing the study. It requires a full commitment because we should be committed to the environment. It's not that we are uh, using environment as a secondary means to justify our mix, and primarily we are interested in the revenue. And that's what actually happened in case of Brazil. But we really have to be committed to the environment, and then only we can think of course, we have to think of revenue, but not at the cost of environment, what was happening in the case of Brazil. So these are the things that will drive uh, the choice of the land, and that will in turn impact the environment. Let's move to the next slide. So we have tried to build one small chatbot here. So I would just like to play it for you. So the chatbot asks us first the first question: how much land do you have? So I say 4 hectares. Then it asks me what percentage would you like to allocate to cattle grazing. So I say 50%. Then it asks me what about the rainforest harvesting. So I say again 50% there. And it gives me the revenue. So if my choice of the land is 50% rainforest and 50%, then this is the revenue that I would be able to generate. Again, the same thing, but we are using NLP here, and that's the purpose, because anyone, a layman, should be able to use this. And that was the purpose behind creating this conversational chatbot. So this is a glimpse of what if analysis. It allows us to measure the revenue or percent land use. In this case, just for the demo purpose, I'm choosing a chatbot which is specifically designed for revenue, but there is one more which is designed for land use also. So how much percent of land would you preserve, or would you be able to save by following that particular mix which you say? And then it will try to recommend that this is the percent. If you use this percent for let's say soybean, this percent for let's say Brazil nuts, then you should be able to generate more revenue. So that is also possible, and that is possible only after building the optimization, that is mix optimization. So, going to the next slide. Now coming to the key takeaways. So key takeaways is obviously the first is forest degradation is projected to increase unless we intervene. So what are the ways that Dave also has shown in his analysis? What is how to build the fire stations, where to build them, and in this case also how to use the land optimally. So soybean and cattle productions have been increasing at the cost of environmental damage. Obviously, we have seen that soybeans are not native to Amazonia. They are associated with deforestation. They are contributors to the soil erosion also. So this is a lot of environmental damage that soybean does. And as we have seen in case of cattle also, they produce a lot of methane, they produce a lot of greenhouse, and they also compact the sand and therefore make it infertile. So, and also we are selling them the cattle for meat, obviously, so ecological imbalance will be introduced there also. So actually these two selections are very poor selections when you think about the environment. Even if they manage you to fetch a lot of revenue, but those should not be the right choice for any of the country just because of the environmental damage. The enormity has to be realized, and one should be very cautious about choosing the mix. Just they should not focus only on the revenue side, and that's how Brazil is doing, and we are seeing the impact on the environment. The other thing is renewable crops like Brazil nuts have potential to minimize the environmental impact, as we have seen, as they are native to the Amazonia, they are habitat friendly, and they have lot, and they have demand also. They are very costly. They bring you a lot of revenue, and so it is not that you are growing Brazil nuts only for the sake of environment. They are also fetching you good money, right? So why don't grow Brazil nuts? Why are you only thinking of soybean and cattle? So Brazil nuts really has a good potential to achieve both the objectives. So why don't we select that? And as we have seen, the underlying factors are like subsidies, for example, unfortunately can be controlled. So really, you can, if you just give more subsidy to the Brazil nuts, then obviously people are will be more inclined to grow Brazil nuts. So again, these things are not just the responsibility of individual farmer, but that becomes the responsibility of entire country also, because of it's just the policies and decisions, the decisions of the farmers get influenced a lot. So these are the takeaways of our analysis for the suboptimal land use. Let's go further and the overall conclusion. Now, overall conclusion is obviously rainforests like Amazonia are at risk. So rampant deforestation is happening for various purposes, for ranching, for other mining, and for all other purposes. So we have to closely monitor them. And analytics can help planning ahead to deal with the risks. As we have seen in the Deb's analysis, if we just plan the proper station, that is proper location of the fire station, then we'll be able to contain the spread of the fire to a great extent. In case of land use also, if we just optimize the land use for better environment, then we should be able to reap the benefits of it. And if we get the diverse data, we get the more insights. Now, what we mean by diverse data is just like we have seen the underlying factors, whether it is subsidies or stock variations. So if we had not gotten that data, then probably our analysis would have got limited, because otherwise how would we predict that these two variables are greatly influencing the target outcome? So once we increase the diversity of the data, we bring more and more variables into the analysis. Obviously, there are a lot of interactions, and those will be captured by our sophisticated models. So we don't have to now bother about the input or the number of inputs, as it was the case previously when there was the era of design of experiments. So at that time, we had to limited resources and all that, and we had to rightly choose the input variables. But now with the sophisticated techniques and so much modeling and with the technology, that is fortunately not a problem. And so the diversity will actually help us here. And now collaboration is from the both sides. One is the technical collaboration, that is we have to continuously maintain that pipeline, the machine learning pipeline that we have built. We have to continuously gather the data, retrain the model periodically, and then run the optimization model on top of it and see if really it is the same, giving us the same results, or there might be some inherent changes in the data also that could happen, and that we have to continuously monitor. And collaborate means there are some data providing agencies like FAO, research institutes, even the governments. We are also employing some organizations like they have employed SAS here. So we are also dealing with some technical experts. There are some domain experts from the Amazon Conservation Association, that is the ACA. So these all entities, when they come together and collaborate, then we can really address the problem at its root cause and try to build some insights, and therefore ultimate decisions that will drive all these efforts to preserve the rainforest. And there are more possibilities. I mean, we have just discussed two problems here, but even though we have discussed two problems, those are not the complete solutions. If we just see at the Deb's problem, where he has found out the base stations, so we can, if we just manipulate the aggregations, we could find the different base stations. And for let's say for the month of July, this is the base station, and for the month of November, that could be the base station. So we can also use the dynamic base stations. So considering the base stations are easy to move, so we can also think of that. So this is again a possibility. In our case also, with the land use, we can take into account not just soybean and cattle. We can take other things in also and see that if we introduce them as a part of the problem, that is the mixed problem, solutions could change. Even if we just see the modeling techniques that we have used, if we again focus more our efforts, do some modeling in the greater details, then probably our solution will differ. So there are a lot of possibilities also. Uh, we just got hold of the FAO style trade, but there could be other data sets also that might be helpful to us. So just the possibilities are very high, and we just have to remain committed, do continuous analysis, and be ready to change whatever policies are there. Be just flexible, and then probably we can really use this analytics to contain the impact, and we will really save our world. So next slide. Yeah. So with that, I thank you a lot for patiently listening to both of us, and we are now open for Q&A.
Thanks a lot, Amod and Deb, for this insightful session. We definitely do have a lot of questions, and we encourage our audience to keep dropping in their questions in the chat box to keep the conversation going. Let's get started with the question title with the time that we have in hand, right? How do you think an organization can ensure the accuracy or reliability or the quality of the data used in this environmental data analytics, right? Based on your experience, how do you think they can ensure the accuracy?
Can you repeat the question?
Yeah. How can organizations ensure the accuracy or the reliability or the quality of the data used in the environmental data analytics that you talked about?
Ensuring the quality of the data. Want to start about?
Yeah. So see, the quality of data, there are certain organizations like United Nations and FAO Stat. Those are actually responsible for ensuring the quality of the data, and we just have to trust them when we use their data. But yes, whatever the data sources that are coming up, we need to ensure that the data is accurate, and then only we can use that. But yes, that there are, having said that, there are still inaccuracies in the data. We cannot get rid of all the inaccuracies of the data. There are certain, because sometimes what happens is they report only 6-month results and not the previous 6 months. So in that case, we have to either build forecasting and include them, or we have to just ignore that data or something like that. But frankly speaking, that is something which is the responsibility of the organizations like FAO, Stat and Comtrade, for example. And the other thing is we have to also give one more round of check to ensure that the data is right.
Got it.
So in addition to that, what Amod says, obviously correct. And just to add to that, I think it's also important to collaborate here, just to ensure the quality of the data. So for example, when we were working on these projects, I think we were constantly collaborating with the ACA. That's a non-profit organization. So what we're trying to do here is we have to collaborate with domain experts. We need to collaborate with maybe institutions to sort of understand the data. I mean, first of all, so if that understanding is clear, so then I think it will be much easier to sort of ensure the quality. And on top of that, there are some technical methods also that are available, which maybe a data scientist or the analyst can perform when he's dealing with the data. So that also can help to ensure the quality.
Got it. So what, according to you, are the ethical considerations should be taken into account, right, while using data analytics in the environmental decision making?
Yeah. So will you bring that caveats or that slide? Because we have discussed that the 5 factors, that is the accuracy of the data and the algorithm that we are using, the periodical assessment, and all other things. These all things need to be taken into account while approaching to solve any problem, because all things matter a lot, and there has to be some demonstrated commitment, inherent commitment that we have to demonstrate, and some of the principles that we have to adhere to while solving any problems. We just don't have to solve the problems just to as a matter of compliance. We have to be really worried about environment, and then only we, yeah. So these are the factors that should be a part of the overall consideration.
Got it.
Yeah.
So there is also a question about, are you aware of any AI-based solution for managing human-animal conflict?
Solutions. No, you want to talk about? I'm not sure about that question, Ashwarya. I mean, what we dealt with in these projects were mostly environment and related to rainforest, but about managing conflicts, we don't have a direct answer, so to say. But if we have the data, anything regarding all of these conflicts, we can definitely think about exploring that data first and then come up with certain techniques to and see whether AI can solve some of those problems. So, I mean, the questions and the answers would start from data. So,
got it. No problem. How do you think the raw data can be consumed from NASA or Sentinel?
The raw data?
How do we consume the raw data from the Sentinel and NASA?
Oh, that's the biggest challenge that we've had. I think both of us and both the problems. Using the raw data was the biggest challenge. We had to use several tools, and we had to also do a lot of research. Some of the raw data files, at least that I've seen so far, were very, very specialized data files related to geospatial statistics. So we had to learn a lot of techniques related to geospatial analysis in order to just get those data files and process them. We had to use several tools, so not just one tool. So for example, we had to use some Unix commands to fetch the data. Then we had to use some maybe Python scripts to process that data. So several things. So I think that's the biggest challenge that we have, and we had to use several tools in order to get that raw data in the right format.
Got it. Thank you so much, Deb and Amol. I think the session today not only addressed the questions that we have in hand, but also I think sparked further thoughts and discussions for sure. A special thanks to each and every one of you present here today. Your eagerness to learn and embrace new technologies demonstrates your commitment to the personal and professional growth as well. Last but not the least, we extend our heartfelt gratitude to our esteemed speaker for graciously sharing their insights and expertise. Their contributions are instrumental in making this webinar both informative and engaging, right? We hope that we will have the pleasure of working with both of you again in future, as Zinnov as an organization continue to strive for excellence in our efforts to educate and inspire others in the field of technology. Thank you once again, everyone, and we look forward to seeing you in our future Zinnov event. Take care and stay safe and have a great weekend. Thank you so much.
Abdul and Aishwarya.
Thank you. Thank you, everyone.
Yeah, have a nice day.